So now for proportion. So one sample proportion. Proportion from one sample. So if you want to do the confidence interval or hypothesis test, you need to check something. That's the NP and NPQ part, right? So sometimes people use 5 and sometimes people use 10. So that's kind of, how do you define it? Let's say you have you put in like $10 billion to develop a drug or into a clinical trial, and it this number should be 10, but you only it will be ideal if it's greater than 10, but if it's just 5, you don't just like, I'm just gonna throw this $10 billion away. You stick through. So 5 is, 10 is the minimum, or if 10 is not really met, you can say 5 is the minimum, and like not lower than 5. That should be like 10 or 5 in each cell. So this is NP and NPQ, and for this one is the same too. Yeah, so P is the number of success over N, and P naught is the hypothesized value of the population proportion. So if you want to calculate the confidence interval, that'll be this one. And actually, an inting slide have this one really clear, so you could like refer back to this one. As you can see, this review is not really hand calculation intense. If you want to have the correct formula, you can go back to his slide. Okay, so this is the example. So here's the study. Use drug way. Okay. With a certain disease. So out of this much people use drug A. So what's the best point estimate? Here, do you remember we were doing estimation before, right? So the point estimate is this one. It's this number over this number. And we want to construct a confidence interval. So so let's check if normal assumption is valid. So we're just gonna do NP and NQ. This one, NQ. So because greater than 10, it is met. And then calculate this 95% confidence interval. Okay, that's just this formula here. Just plug everything in. And then interpretation, where 95% confidence interval, person sure that the true is between these two numbers. And for exact binomial test, data can calculate confidence interval for you. So for summary statistic, you're using this command, or if you're from raw data, you're doing this command. Okay. And for hypothesis test, example 1. So there are 200 people are giving a drug, and the drug is effective in 30. So that's 30 out of 200. Okay, yeah, so that's the point estimation. Yeah, we got it here. And then suppose research said that this is effective 20% of the time. So we want to test if the alternative, is not. So state the not is equal to 0.2 and HA is not equal to. And so check that the normal used to chalk for normal stuff that's NP and NQ is all greater than 10, and then we're doing this test, and because we're testing is equal or not, so this is the one we're gonna choose. It's 0.07. So because it's greater than alpha, we fail to reject H0, and state the conclusion will be we do not have sufficient evidence to conclude that. So what I want to do something here is I want to show you can I do this? So all of this part is your decision. And all of this part is your conclusion. Yeah, so you decision, conclusion. So sometimes it's kind of specific. You need to say it. So this is decision. Decision means I reject, I do not reject. Conclusion, you're just gonna say, if you reject, you are gonna say, we're just gonna say it's smaller, it's not equal, it's greater. And if it's what did I say? So if it's reject, we're just gonna say, so if decisions reject, we're gonna say, the conclusions we're gonna say it's not equal, it's smaller, it's greater. If it's do not reject, for the decision, to the conclusion, we're gonna say we do not have enough evidence to say it is not equal or greater or smaller. Okay. And now, to the second example, so there are like 7 out of them, and there are 50 out of 7. No, that's 7 out of 50. So this is the point estimate, and we want to test. This is the number we want to test. So still, right? So check this one, and now here we're using 10 as a rule of thumb. So because it's smaller than 10, this one is smaller than 10. What should we do? We're doing exact binomial. Or, if your sum room is like 5, you could still do it, but yeah, to use 10. But here, why I'm choosing 10 is because I want to, there's another way to do this, so I'm just, because it's the second example for the proportion test, I'm going to use a different method, a different test, right? We're going to use exact binomial test, this one. So this is the command we're going to use. And so, yeah, so this is the result. We are doing a two-sided test because it's two-sided, right? Now, so two-sided test, and here because the p is 1, so we're gonna say, since p is 1, it's greater than 0.05, so we do not reject. So here still, this part is decision. We do not reject. And then this part is a conclusion. We say we do not have enough evidence to say that it's not equal to 0.05. Okay, so here's the command for one proportion test. If you have any problem, you can email me about how to use this command. And now, this two sample proportions. Okay, do you remember this? We just did this a few minutes ago. Now, you see, let's do it again. Two group dependent, yes, that's gonna be parity test. No, we're gonna ask the variance of the two groups. Are they equal or not? If it's equal, it's unpaired t-test with equal variance. If it's not equal, it's unpaired t-test with unequal variance. Okay, now we have this. Yes, this is so much simpler, right? So if it's dependent, now we're doing this for proportions, right? If it's dependent, we're using this test, and if it's independent, we're using this one. I don't think this, okay, I don't think this one is gonna be really common. I still put everything here just to, so if you're interested, you can just follow through. But we're not gonna cover it. We're not gonna get in specific here. So here, so if it's dependent, you can get a table like this, and then you do, like, I colored everything, so like A, B, C, D, you just put in this through the order, and this light pink is gonna be the test statistic, and this one is a p-value, the purple one, and then here are decision and the conclusion. Oh, okay, this is what I mean. Decision and conclusion. So decision is we reject it when this happened, we refuse to reject when this happened, and conclusions if we reject or not. This is like textbook grade decision and conclusion. You just copy this and use it somewhere else. It sounds really professional. Yeah. I'll go, okay. And now let's go next. 2 sample z-tests for proportions. So still, you do the table here. You see this one? This is the 5 now, right? So you do this. You do the table here, or you can just write it out. And this, if it's one-sided, this is the H0 and H1. Okay, this is something. This should be 1. This should be 1 too. Okay, and then this is the conditions, right? Now, the first way you can do this, you can test this way, or you can test this way. So first way you're doing this is this way, and then you have the test statistics and p-value, or you can do this way. So the test statistic and this value. As you can see, these two are the same. Okay, now here the decision and conclusion is still the same like last one. And now this is the command for 2 proportions. Okay, now this is the overall command for 1 proportion and 2 proportions. Okay, yeah, that's the end.